Hi, my name is Dr. Vijaykumar Varma. Today we will be learning about a magnetic measurement technique which is very routinely used for all the magnetic materials. It is called as VSM, which is vibrating sample magnetometer. So I will be covering up some basics and then the complete very detailed demonstration of the VSM operation. So let's understand the working principle and some of the main component of the system first before going into the VSM demo. The main components of a vibrating sample magnetometer are electromagnet with two pickup coils, then a vibrating head. This vibrating head is connected to sample holder, so sample holder oscillate due to this vibrating head, and it is connected to a lock-in amplifier to refine the signal which is obtained from pickup coils. So other components which are required for the running of the VSM are a power supply and a data acquisition system. So data acquisition system is very important because it will allow the system operation, like you define some program, then system will operate according to that program, and it will acquire all the data collected from after the measurement. The components which are not shown here consist of heating and cooling unit, which generally consist of uh, some heater for heating your sample for the measurement of curie temperature, and for low temperature measurements you need to connect this system um, to a cooling unit consisting liquid nitrogen. It also require chiller um, for power supply and for electromagnet coils for their cooling. The working principle of vibrating sample magnetometer can now be described. When sample is mounted inside the electromagnet pole pieces, then it will get magnetized, and as it magnetized, it will behave like a small magnet inside the system. And when this sample oscillate inside the pickup coils, it will generate a current pulse which is proportional to its magnetic moment, and that is how magnetic properties of the system is measured by using VSM. Now let's start the VSM demo. It will start with the description of the system components, followed by turning on procedure of the system, then how to mount a sample holder inside VSM, and defining experimental program for VSM measurement, measuring a sample, and turning off procedure of the VSM.
Hi there, my name is Dr. Vijaykumar. Today we will be learning about vibrating sample magnetometer, which is one of the very accurate method for magnetic property measurements. So you already got yourself familiar with the principle of the magnetometer and what are the magnetic properties which we usually focus on for the measurement. So whenever we require to use magnetic materials, we need to measure the specific magnetic properties. For example, if you want to use a magnetic material for thermomagnetic application, then in addition to magnetization, magnetic susceptibility of the magnetic material, you also need to know its thermomagnetic response, its curie temperature. and so on. So similarly for biomedical application, we want very high magnetization and low persitivity. And to know all of that, we require to quantify material properties, which we do by VSM. So what are the main components of the system? So let's start with this side. So here we have a chiller, we have a power supply, then we have the main component of the system, which is uh, this magnetic coil in the form of electromagnet, and then the head of the system, the core of the system where everything happens, the main action happens, which is this head drive unit. And then of course we need to have a software based measurement. So this system communicates with the software, and then software calibrates the measurement. So here we have the computational unit, or you can say control unit. So these are the main components of the system. Now let's go to more details. Now can you tell me what do you see here? So of course these magnetic coils, a core which is a soft magnetic core. Then you also see coil pieces in the form of a core which is like flattened on each side. So it forms the pole faces, and then we also have this small probe, which we call as all probe, and inside that you see two coils. These two coils are very important. So these are the pickup coils. So what happens inside this zone, as we described earlier, the sample get magnetized, and sample get magnetized and vibrate inside these coils. So it generates current, and that current is then picked up by these coils, and that is what this system calibrates. Which we can now see clearly. So all probe, voltage, and magnetic coils, these pickup coils.
So to turn on the VSM, what we need to do is turn on one switch at the back side, then chiller switch, and now we will turn on the power supply, which is shown here. Now before starting experiment, we need to reset field and current conditions. This will set the initial background for the measurement. So we want that background to be 0. Moreover, this is good for to prolong the life of the system. So to do that, here we have toggle buttons. One, the default condition is set to current, so we need to ramp up to 0 current first, and then select the top button to field mode and set it to 0 field value. So now as you see here, experiment is running and it will ramp to 0 current initially, and then this process will we will repeat for 0 field value. So now we know how to set the initial conditions, and now let's load the sample. So to load the sample, we first need to remove the blank. So to remove the blank, we need to rotate the screw in anti-clockwise direction very slowly, and once blank is removed, we are ready to. Let's take a look of sample holder first. So this is how sample holder looks like, and we need to. So this is the sample holder is for uh, magnetic materials in the form of particles. So it's screw type sample holder. So there is a sample mount we need to properly align at the top as shown now. So with careful alignment and mounting, we can place the sample, align, and then rotate the screw in clockwise direction to mount the sample holder, and make sure that the sample holder is at the center, so it should be straight. So we have a sample holder, and then sample is mounted at the between two poles of the electromagnet. So how does the typical experiment program setting looks like? So that is what we will be going through now. So the initial part is done, that was required with, you can say, preset above the system. Now let's set the program and then run the experiment. So to set the program, so that is what you will see at the screen. We have various toggle buttons as I have described before. So we will first ramp the system. So we will turn on the head drive first. So that is the first step. Then ramp the current and field to 0 if you didn't do it, and then we will set the program uh, from this tab, the first tab. So sample name and IDs are entered, and now we have this program window here. So it is named as experiment. So we entered some name for this experimental procedure or program, which we will be all the time using. So we started the program setup. So first step is to select the cycle, type of cycle we want. Then number of points, ramp rate, and so on. So all those factors will determine how long you want to run your experiment. So this typical experiment which I have selected will run for 11 minutes. So there are around 100 points. So time you can see at this window. So for this case it was around 11 minutes. And then we need to select some other setting like auto center the profile, then which type of measurements we want, which one of values of the measurement to be displayed on the screen, and so on. So this is to which values to be displayed on the screen, and then what data we want as the output after experimental is completed. So we can select a range of parameters. So I have selected a resonance field, then magnetization, magnetic moment, then uh, details of the setting as well, sample weight, and so on. So those things you can select from top and then um, save it to this particular setting. So after that only one thing is required, which is to add the sample weight. So that is required when we start the experiment. So now let's enter weight of the sample by opening the window, and then experiment will be started by clicking on the start button. Now let's go through one experimental run for VSM. So the typical experimental run, which I have already described, will start by pressing this start button here on the screen, and once it is started, then we will wait for around 11 minutes, and then we will have our final measurements as the output. So now experiment is started, and as soon as a few points are generated, you will see um, the uh, MH or BH loop will be displayed on the screen. So now this measurement will go on for 11 minutes. The turning off procedure is exactly opposite to what we did at the start of the experiment. So once experiment is completed, we will toggle to field and ramp mode and then ramp it to 0 values. So that is the first step, and then we will be stopping the head drive to stop the vibrations and remove the sample. So these are the steps which I am currently doing. So field and current values are ramped to 0, and now let's turn off the head drive, the first toggle switch. Once head drive is off, we can move to next step, which is the removing of the sample from VSM. So carefully rotating in clockwise direction to remove the sample holder and mounting the blank in the head drive. Like same earlier step, align along the cavity. You see with a small stud to align, and then rotate the screw to fix it. So once we did that, we need to turn on the head drive again. So remember, we will always be keeping head drive on when experiment is completed and the blank is mounted. So again, just to be on safer side, I'm ramping it to 0 values, ramping current and field values to 0. And removing the standard from the sample holder and keeping it back. So final stage after this is to turn off the power supply and chiller, which I am doing now. So by pressing the red button to turn off the power supply and then the 3-phase button here, and finally turning off the chiller. So this will complete the turn off procedure of the VSM.